Good afternoon, everyone. My name is Shane Webb, and I'm a Metal Earth postdoctoral research fellow at University Laval. I've been in Canada since June, so I've been doing this project now for approximately 8 or 9 months. Those of you who were present for the Metal Earth meeting in Ottawa in fall may remember that I was about to return to Kirkland Lake for subsequent fieldwork and sampling. So in today's presentation, I'll be summarizing what was accomplished during my recent fieldwork and sampling campaigns, but also providing you with a detailed overview about the analyses that I'm doing as part of my postdoctoral research. For those of you who perhaps don't know me or were not present at the fall meeting, I'm just going to provide a quick overview of my postdoctoral research. There are several of us at Laval who are investigating the fluid sources and mineralization ages of the breaks within the Canadian Shield. For example, Shafak Sonmez, who will present after me, is looking at this question along the Porcupine-Destor Fault. My project is essentially the same thing, except I'm looking at the gold deposits along the Larder Lake Cadillac Break, which is a structure that extends for over 250 kilometers. It typically cross-cuts Archean komatites and metasediments. There are several world-class gold deposits in this region, for example, Macassa, Young-Davidson, Canadian Malartic. The Metal Earth team and other researchers have established the mineralization ages and fluid sources of the area immediately to the east of Canadian Malartic rather well, so around Val d'Or. However, with regards to this question to the west of Canadian Malartic, there is considerable uncertainty regarding the fluid sources and mineralization ages, particularly between Rouen-Noranda and Shining Tree, which is the focus of my own research. So after I left the Metal Earth meeting in fall, I went to Kirkland Lake, where I spent just over 2 weeks. Most of my time was spent conducting underground sampling in the South Mine complex of Macassa. Here's a picture of me doing that. Although whenever I was at Macassa, I was also able to log core and sample core from the other mineralized systems at Macassa, for example, the 004 break, the main break, the amalgamated Kirkland break. During my stay, I was also able to visit a core shack near Rouen-Noranda and log and sample core from the Wildcat vein. For those of you who don't know, the Wildcat vein is a zone of orogenic mineralization within the Wasamac deposit. I think that Wildcat was actually the historic 20th century Wasamac mine. Another more peripheral objective I completed was logging and sampling core from Munro. That's a much smaller orogenic gold deposit along the break as well. At the start of December, I went to the Royal Ontario Museum to collect samples from the historic Kirkland Lake gold mines, for example, Wright Hargreaves, Toburn, Lake Shore. These localities are quite important because they represent different parts of the same Kirkland Lake gold deposit that is currently being mined at Macassa. Unfortunately, given the rarity of some of these samples, I could only take quite small pieces from the museum, so they're probably going to be more important for the purposes of regional stable isotope studies, which I'll be talking about a little bit later on. So this map represents the updated sample distribution. So since my samples are shown by the yellow dots, since the previous Metal Earth meeting, I've been able to increase the number of dots on this map by about 10 to 12. So I'm really in a position now where my priority is to continue preparing the samples for analysis and then ultimately analyze the samples to get the necessary data. I would point out that there are still a couple of gaps in the sampling coverage, for example, around Young-Davidson, where I hope to go in the coming months, but also around Shining Tree, I only have a couple of samples. This feeds into future work, so I'll be talking about this more at the end of my presentation. So in the way of previous geochronology from my area, as mentioned earlier, the Metal Earth team has done in situ uranium lead dating on xenotimes around Val d'Or, identifying 2 major episodes of orogenic gold mineralization at 2686 MA and also 2643 MA. Now, some of the limited geochronology that has been done from the area of the break that I'm looking at actually shows some similarity with that older mineralization event, which ultimately may suggest that, well, perhaps the older mineralization event has been regional along the break. However, some limited rhenium osmium dating from Shining Tree has reported slightly younger ages, which may in turn suggest that, as with Val d'Or, there have been multiple different mineralization events along the Larder Lake Cadillac Break. The only way that I will be able to investigate this, though, is through geochronology by actually dating the samples. I should note that I did consider the possibility of doing rhenium osmium dating on the molybdenite samples that I have, particularly from the Kirkland Lake gold deposit. However, my molybdenite samples were too sheared and deformed for us to be able to try and get reliable dates out of them, so I'm going to be really sticking with the original plan of doing petrography to identify phosphatic phases prior to in situ uranium-lead dating. I'm fairly optimistic that this will be successful because I've spoken with other people who have done thin section characterization on some of the localities that I've sampled, and they have described, or they say that there are phosphatic phases there, so it should realistically be possible for me to do this. For the actual plan of geochronology, I have made at least one thin section from every locality where I consider it possible to do geochronology, and by that I mean every place where I have a well-characterized sample, which will ultimately provide the necessary context to really interpret and consider the significance of the geochronological results. However, I think that my project will be more impactful if I date the bigger deposits in the region like Macassa, Wildcat, but even some of the slightly smaller ones that are still being commercially investigated like Fernland or Cheminis. So in order to expedite this process, I recently sent approximately 60 rock chips to a thin section lab in Vancouver that I should get back pretty soon. Those 60 rock chips predominantly come from the bigger deposits, so I'm going to look at as many thin sections as possible from the bigger deposits to maximize my chances of finding datable minerals. Regardless, the plan with geochronology will be, when I get the thin sections back, see which ones have datable minerals in them, which ones are maybe quite limited in their potential for having datable minerals, and then prioritize the samples accordingly. So with oxygen isotope studies, there is actually quite a large body of work that has been done from my area, mainly by the Metal Earth team. Previous analyses are shown by the purple dots on this map. Generally speaking, around Kirkland Lake, the 18 oxygen isotope values of quartz have tended to be between plus 16 and plus 18 per mil, which some people have interpreted as being evidence of a metamorphic derived ore-forming fluid. However, around Young-Davidson and Shining Tree, the values are slightly different. There, it's typically between plus 10 and plus 12 per mil, which some other people have interpreted as being evidence for an oxidized magmatic hydrothermal fluid. So this may suggest that there have potentially been a variety of fluid sources involved in the formation of the different gold deposits throughout my area. So for my own plan with the oxygen isotope analyses, it really is a case of filling in the gaps because a large body of work has been done from this region already. However, there are some gaps in the previous coverage. For example, immediately west of Kirkland Lake, there are a number of gold-bearing veins for which I could find no data from. Interestingly, in the historic Kirkland Lake gold deposit, in the original mines like Toburn and Wright Hargreaves, there's a bit of a dearth of data there as well. So I will probably focus on generating more data from those samples, as well as a few isolated occurrences between Kirkland Lake and Rouen-Noranda that have been missed during the scope of the previous studies. You may remember at the fall meeting, I talked about doing OH pairs on my samples. Now, I should note that the difference between fall and now is that over the last several weeks, Shafak and I have been preparing our samples for oxygen isotope analyses. We've been crushing the quartz, we've been separating it and pulverizing it ultimately for analysis. So I've really been able to engage with my samples, separate them and see what's available. And this has enabled me to identify which samples have enough tourmaline, which samples have enough chlorite for us to do a pair calculation. For those of you unfamiliar with this concept, the underlying principle is that if you work out the oxygen isotope composition of quartz and then the hydrogen isotope composition of a co-evol mineral phase, such as tourmaline or chlorite, it can help you estimate the temperature. Based on my preparation, or rather crushing of the samples to date, I'm pretty optimistic that I can get 10 temperature calculations from about 10 localities along the break. Those of you who've worked in the area may be aware of an observation that, generally speaking, west of Malarctic, the orogenic style veins don't really have as much tourmaline in them. However, my experience has been that with regards to the orogenic style veins in my area, for example, Wildcat, the veins around Lac Fortune, Anoki McBean, also the Gatling properties like Fernland, they generally tend to have quite a lot of tourmaline in them. With the other localities shown here, it's a case of where those samples have quite a bit of chlorite in the quartz veins, and it will be fairly straightforward for me to drill them out of the sample using a Dremel. So with regards to previous sulfur isotope studies, it seems like there has been a bit less work done relative to the oxygen isotope studies. I should note that this compilation here represents what I have found in Google Scholar, old Ontario Geological Survey reports, as well as some MSc and PhD theses. It is, of course, possible that there may be some data that I'm unaware of or missing. So if any of you feel that way, please let me know at some point during this conference. Most of the previous sulfur isotope data from the region tends to come from the cyanite-hosted deposits, which, and as such, the delta 34 sulfur values from these deposits has typically been quite depleted. Other people who've interpreted this data have interpreted as being a sign of the influence of an oxidized magmatic hydrothermal fluid, although that's somewhat unsurprising given that most of the data comes from these cyanite-hosted deposits. I think it will be interesting in my project to compare the sulfur isotope signatures of the orogenic style veins with the cyanite-hosted deposits. My plan for sulfur isotope studies is largely unchanged from the meeting in fall. The plan is for me to initially focus on generating bulk sulfur isotope data first, so getting the Dremel, drilling the pyrites out of the sample and storing it in the vials before sending it into a lab. Shafak and I have found a lab that can take our samples at the University of Ottawa. So what we will do, so we are in a position where we've got all of the samples out, and when we return to Quebec, we will use the Dremel to drill the sulfides and then send them all to the lab in Ottawa. After we get the regional studies back, we will then probably start identifying localities as to where in situ sulfur isotope analyses would be interesting. However, I should note that I strongly suspect that I will end up doing the in situ sulfur isotope analyses on samples that I do geochronology on, because those are realistically going to be some of the samples that have the greatest petrographic and paragenetic context for the data, meaning that you can assess how the sulfur isotope signature varies throughout the evolution of each ore body. I want to just use this slide to briefly touch upon some other studies from the region that may be relevant. So this map comes from a 2017 publication in Ore Geology Reviews, and it shows how previous researchers have divided the different sections of the break up in terms of which ones host intrusion-related mineralization, which ones host orogenic style mineralization. So you can see, for example, around Rwanda, they've categorized this as being orogenic gold mineralization, whereas around Kirkland Lake, they've classified that as being intrusion-related. Although, based on the present state of knowledge that we have about the area, making such divisions can sometimes be quite controversial and difficult. So using the Kirkland Lake gold deposit as an example, there is an emerging consensus now that yes, the mineralization here is related to magmatism. The mineralogy and geochemistry of the deposit would appear to support that, as would the igneous host rock. There was also a recent study using lithium isotopes, which was able to fingerprint the involvement of magmatic hydrothermal fluids. However, in the literature, you can find references to the Kirkland Lake gold deposit as being orogenic, mainly because the oxygen isotope data that was reported from some of the other systems here was in line with such an interpretation. And I think at present, even though the deposit appears to be magmatic, there is no known co-evol intrusion in the region that can be invoked to explain the magmatic hydrothermal fluids. So my hope is that by doing various kinds of stable isotope studies, by implementing the sulfur isotope studies, and importantly geochronology, it should be able to help us get a better sense of the affinities of the different deposits along the break, whether they are intrusion related, whether they are ultimately orogenic style mineralization. So I want to, even though I've been referring to it throughout, I want to briefly summarize where I'm at in terms of the analytical work. As mentioned, Shafak and I have been doing the oxygen isotope preparation for the last number of weeks, and when we return to Laval, we should be able to start running the oxygen isotope line and generating the data. With regards to the thin sections that we've sent to Vancouver, we should start to get those back next week or the week after next, meaning we can imminently begin the necessary petrography that will fundamentally underpin the geochronology. Then in mid-March, we hope to send our samples to Ottawa in order to get the ball rolling with the regional studies on the bulk sulfur isotope values. And then this ultimately all feeds into our longer term aims of doing geochronology later in the year, and hopefully in situ uranium-lead geochronology, as well as the in situ sulfur isotope studies. I want to also now just briefly touch upon future sampling plans. So you may remember that at the start of the presentation, I noted that there were still a couple of gaps in the sample coverage that we have derived. I'm hoping to visit Young-Davidson in the coming months to sample some of the veins hosted in the syenite there for the purposes of geochronology. The reason why I held off on that last year is because there is a PhD student at the University of Toronto who is doing a PhD that is very specific to Young-Davidson, and it wasn't clear at that stage whether that project would actually involve geochronology. It will, however, involve a significant component of stable isotope studies. So now that, because I've been in contact with that student, I've been able to see how that project has progressed, and I now know that she will not do geochronology, which means there is an opportunity for me to visit here and collect some samples. I also mentioned Shining Tree, where there's a bit of limited coverage. Fortunately, I have a contact at the Ontario Geological Survey who told me he thinks that they may have some core samples from the Shining Tree prospects in the OGS core archives. So if that turns out to be possible, or if it turns out that they do actually have those samples, I will probably go there as well to improve sample coverage in this region. So just to conclude, this project obviously is fairly diverse in the sense that it covers quite a large area. It involves the use of different approaches of analyses, geochronology, sulfur isotopes, oxygen isotopes, OH pairs, as well as petrography, which means that because it's been diversified, it helps to minimize the risk of certain analyses not panning out as expected or failing. So ultimately, it should still be possible to get publishable data. The last thing that I'll say is that as part of my project now, I've compiled a very large collection of samples, all of which I probably will not analyze, so there may be scope for other people, if they're interested in this region or doing research on some of the localities around Kirkland Lake, to access these samples. So if so, feel free to get in touch with me. Thanks for your time. I'm happy to take questions.